Alright guys, today we're going to be talking more about how to do solving equations. That's what this entire unit is about. So we're ready for lesson 2.2, talking about solving two-step equations. The first part of this wants us to complete this graphic organizer. It says go back through your chapter and see which one of these matches up with which one. Well, if I look at this very first one says the addition property of equality. The addition property of equality says that if I have subtraction in my original problem, then I'm going to do the opposite operation of addition. So I want to find one of these problems that has subtraction. Well, if I look at this first one, I have 1/2 and an x side by side, which means that's a multiplication, so that's not it. This one is a 3 times x, that's a multiplication, so that's not it. Here I have an x plus 3, that's addition, so that's not the problem I'm looking for, because remember I'm looking for subtraction. So this last one shows subtraction, an x minus 5 equals 6. So this first box needs to be drawn a line all the way down to this last box, because in this box I am subtracting and I want to do the opposite of that action and I want to add. That's the addition property of equality. Now let's look at the division property of equality. The division property of equality says that I'm multiplying, but then when I go back through, I'm going to divide. If I look at this first one, yes, I'm multiplying 1/2 times x, but what I'm really doing is I'm multiplying times the inverse. So that's not division. In this one, I'm taking 3 times x and I'm doing the opposite operation, which means that I'm dividing. Right there is the one that I'm looking for, is where I divide in step 2. So that draws straight across. Multiplication. Now I'm looking for the one where I multiply in step 2. Hopefully you can see that in this top one I'm multiplying in step 2. And then finally my subtraction property of equality is where I subtract in step 2. So let's go on and read this down here. It's talking about a property in science. And it wants to know, how is the definition of property similar in science and math? Well, if I look at a property, these never change. These properties are always the same. They're like law. In science, a property is the same way. If I think about water, water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. That never changes. Water is always going to freeze at that temperature. So how is the definition of property similar in math and science? The property means it never changes. It is always going to be true. And that's regardless of whether you're talking about science or math. Whatever the property states, it's going to be true no matter what the problem. Water is always going to freeze at 0 degrees Celsius, and the addition property of equality is always going to say that you subtracted the second step. It is never going to change. So let's look at some examples. Today we're talking about two-step equations. The last video that we did in section 2.1, we talked about one-step equations. We had to do one thing in order to get the variable on a side by itself. So today we do two-step equations. Hopefully you understand that that means that we're going to have to do two things in order to get the variable by itself. So let's look down here at method 2. Method 1 talks about algebra tiles, and we don't always have access to algebra tiles, so it's best that you just know how to solve them without algebra tiles. And number 2 talks about that. If I look at number 2, first of all, you're always going to draw your equal line down. So here I have a 2x plus 3 equals 7. I want to only focus on the variable side. So this is the side that I want to focus all of my attention on. The first thing that I'm going to do is I'm going to move everything that's not attached to x. This 2 is attached to it because they're side by side. This plus 3, though, is not attached to x, so I'm going to move it. It was a positive. Whenever I do the opposite operation from plus is minus, so I'm going to subtract 3 from both sides. So my 3's are now gone, and I'm left with this 2x on this side. Well, hopefully you remember that whatever I do to one side of the equation, I must also do to the other side. So I started with a 7. When I subtract 3, I end up with a 4. So now I have a 2x equals 4. In order to get this x by itself, right now I have 2 times x. There's not a multiplication sign in there, but hopefully you know that when they're side by side, that means that you multiply. So 2 times x, the opposite of multiplication then is division. So I'm going to divide both sides by 2 because the 2 is what I have to get rid of in order to have x by itself. When I do that, the 2's are gone. They cancel each other out, and I'm left with an x, and 4 divided by 2 is 2. So there's my final answer. Let's look at letter A. First of all, you always draw your equal sign down. That should be your first step no matter what the equation is. And then I'm going to focus on the variable side, the side that has the letter. And it says 3x plus 2. I want to move everything not attached to 3x. So I'm going to move everything not attached to this part right here. And if I look at that, the thing that is not attached to that is a plus 2. So the opposite of plus 2 is a minus 2. So I'm going to subtract 2 from both sides. My 2's cancel out because 2 minus 2 is 0. And I'm left with a 3x on this side. Then I have a 20 minus 2. 20 minus 2 is 18. Then I have to do my next step, and that means that I have to get rid of whatever's attached to x. Well, in this case, I have a 3 times x, so the opposite of times is to divide, so I'm going to divide both sides by 3. My 3's then cancel out, and I'm left with x equals whatever 18 divided by 3 is. If you need to use a calculator, go ahead and figure that if you already know it. 18 divided by 3 is 6. Go ahead and try B on your own. Stop the video. All right, hopefully you've had an opportunity to stop the video and try B. We'll go over that in class. Now let's talk about example number 2. Example number 2 is the same concept. I'm going to be using 2 steps in order to solve this equation. So draw your line down from the equal sign. Focus on the variable, the side that has the letter. And I want to move everything not attached to 1/4 n. Well, the thing not attached to 1/4 n is a -3. So when I do the opposite of -3, I'm going to add 3 to both sides. That gets rid of my 3's, and I'm left with a 1/4 n on this side. 25 plus 3, excuse me, is a 28. So now I have a 1/4 times n equals 28. Because I'm multiplying 1/4 and n, that means I'm going to divide by 1/4 on both sides. And hopefully you remember Mr. Neugebauer talking about whenever I divide by a fraction, I'm really multiplying by the inverse. So rather than dividing by 1/4, I'm actually multiplying by 4 over 1, and 4 over 1 is 4. When I do that, my 1/4s are gone, and I'm left with n. And 4 times 28 is 112. So my answer is n equals 112. Let's do letter D together. Draw your line down from your equal sign. Focus on your letter side, your variable side. Now I want to move everything not attached to 2/5 r. And the thing not attached to 2/5 r is this -5 right here. So I'm going to add 5 to both sides. My 5's then are gone. Bring down your 2/5 r. 7 plus 5 is 12. And now I'm going to divide by 2/5, but remember, whenever I divide by a fraction, I'm actually multiplying by its inverse. So I'm going to take 12 and turn that into a fraction. Any number turned into a fraction is just over 1, so it's 12 over 1, times the inverse, which is 5 over 2. So now, if I multiply across, 5 times 12 is 60. 2 times 1 is 2. So now I know that r equals whatever 60 divided by 2 is, which is 30. And that's your final answer. The last example that we're going to do together is number 3. Number 3 says 6 minus 3x equals 21. No different than anything else. Draw your line down from the equal sign. Your equal sign line should always be straight. That's where your equal sign always is. And I'm going to focus on the side with the variable, with the letter. Right now I have a positive 6 minus a 3x. Well, because it's a positive 6, I'm going to do the opposite to both sides, which means I'm going to subtract 6. So I subtract 6 from both sides. My 6's then are gone, and you bring down your negative 3x. 21 minus 6 is a 15. So now I'm going to divide by whatever number is multiplied by x. And if I look at this, I have a negative 3 and an x side by side, which means I'm multiplying a negative 3 times x. So I want to do the opposite. I'm going to divide both sides then by a negative 3. And a 15 divided by a negative 3 is a negative 5. The most common mistake is that you forget this negative on this 3. Make sure whenever you divide, you don't divide by 3, you divide by negative 3. Let's look at letter F. Draw your line down from the middle. That's always step 1 from the equal sign. And I'm going to focus on the variable side. So I have a negative 3x plus 2. And I want to move everything away from the negative 3x. So I'm moving everything away from this part right here. The part that's not connected to that then is the plus 2. The opposite of plus 2 is a minus 2, so I'm going to subtract 2 from both sides. So I end up with a negative 3x left on this side. And a negative 19. Take away 2 more. Some of you are saying it's negative 17, it's negative 17. No, it's not, because they're both negative. I have to add them together. So my actual answer is a negative 21. Okay, that trips you guys up a lot. We have a lot of problems with adding and subtracting integers. A negative 19, take away 2 more, is a negative 21. And then I want to divide by whatever's connected to x, because right now I have a negative 3 times x, so I'm going to do the opposite. I'm going to divide both sides by a negative 3. A negative 21 divided by a negative 3. Hopefully you remember that a negative divided by a negative is a positive. So my answer is a positive 7. Okay, make sure you guys write down any questions that you have and bring those to class tomorrow. If there's anything that you're unsure of, make sure that you jot that down so that you remember. And do those other got it problems, the ones that we didn't do with you in class, and you're probably going to see those again on a test or on a quiz. We'll talk to you guys later. Good night.